My name is Jennifer Bland. I'll give you some information about myself. I'm a senior software engineer working for Hearst Autos, which is literally next door at WeWork. How many of you have ever heard of Hearst Autos? Okay. How many of you have ever heard of Cosmopolitan Magazine or Cosmo? All right. Since we got a lot of guys in the room, how many of you have heard of Car and Driver Magazine? Okay. Hearst Media, which has over 300 magazines that they publish, is the 7th largest private company in the United States. Cosmo is their bread and butter magazine that they publish. And about a year ago, they bought a company out in California that had a portfolio of magazines that they produce. And they brought them in-house, and most of what Hearst publishes are women magazines. They're based off of fashion and stuff like that. And as part of buying that company, they realized that, okay, now we've got Car and Driver and Road and Track. And we mainly do women and fashion. And that's clearly a male-dominated magazine. And they were like, we don't want anything to do with it. It doesn't fit our model. This isn't what we do. So they were like, we'll take all the magazines in, and then we'll just spin this one off and sell those magazines separate because it doesn't fit our model. And what happened was somebody pointed out to Hearst, do you have any idea how much money those websites and those magazines produce? And then they started thinking about it from a business standpoint. Well, maybe we shouldn't get rid of them. So, but they were like, it still doesn't fit our business model. So what they decided to do, we're going to create a startup company. We're going to call it Hearst Autos, appropriately enough, because it's going to cover Car and Driver. We're going to put it here in Atlanta, and we're going to, let them handle just Car and Driver. So the website caranddriver.com is what we work on. And so they started. We haven't been in business for even a year. It's the fun and thrill of working at a startup. But you have the safety net of you're basically financed by the 7th largest private company in the United States. So we know that we're not going anywhere whatsoever. So we've been working on it. We've only been in business for about 8 months now. We already have 50 employees, and we're on track before the end of this year, hopefully to grow to 100 employees. And we are hiring, so I have some details about that at the very end. So I'm going to be talking about promises and generators in ES6. So I'm going to talk, first half of my presentation is going to be on promises, and then the last part of my presentation is going to be on generators. So if I was going to write a book on promises, it would be titled, It All Started with Callbacks, and the very first line would start off with, it was the best of times, it was the worst of times when talking about callbacks. So let's start with the very basics of what is a callback exactly. And I could give you the MDN definition of what is a callback, but it doesn't make good logical sense to understand what they're saying. But in very simple terms, a callback is basically saying, when this piece of code over here finishes running, then I want you to go execute this code. So you don't execute it until you finish, and that's basically what a callback is, and that's what a callback does. Oh, we came undone? Are we in business now? All right, sorry about the interlude there for the AV problems. All right. So basically what we have is when you look at how async code works within JavaScript, you have to understand how JavaScript, the event loop, execution loop, goes through. It's a single-threaded event loop. So basically when you have code, it takes the very first line of code, it executes it. Then it goes to the next line, and then it goes to the next line. And it keeps that following that promise until it gets all the way till the end of the code, and then it finishes because it's finished. If you have something that's asynchronous code, what will happen is that when you execute it, it will immediately return, and then the code will go down to the very next line and start executing on the very next line and so forth. When that asynchronous code that you remember what I was saying earlier, when this code over here finishes, go run this something other code, Well, when this one finishes, it sends an alert to the execution scope, and when it's going down and it sees that, it says, okay, let me stop where I am. I'm going to jump back up here and take that code, and then I'm going to execute whatever the callback told me to execute. And then when that finishes, it's going to jump back down to where it was and keep going in the process. And so that gives you an idea of how asynchronous code works. So when you look at callbacks, traditionally in JavaScript functions, they start looking like this. You notice how it indents in. And this gives you kind of a real-life example. Let's say I'm at a university, and I want to run a function. I'm going to pass in the name of a class. So I'm looking at Accounting 101. And I want that function to return to me every student that's taking Accounting 101. And it could be in the history of the university. It could be for a semester. It could be whatever. So we're looking for all the students that have taken Accounting 101. Once it's gone out and gotten that list of students, then the next thing it's going to do is it's going to get the student details. I'm going to pass into it all the information about the students that I've got from the first function into the second function, and that's going to give me the details about the student. You know, maybe like what dorm the room they're in, what class they're in, what schedule they're taking, how many courses they might be taking. That might give you an idea of the details that might be returned. Then when that function is finished, it's going to then call the last function, which is get juniors. So I want to pull out of all those lists of students, all the juniors that are in there with all their details that are in the Accounting 101 class. And then once I've finished, I'm going to console log out the results that gives me that. And a lot of times from a terminology standpoint, from a programming standpoint, this is called the callback pyramid. So if you kind of like look at this, if you rotate it at 45 degrees and start looking at it, you can see that it kind of indents with the code of how it's done. Now, when you become a senior programmer, you get to call it callback help. So it's a pyramid when you're a junior programmer, but when you're a senior programmer, it's called callback help because it just kind of seems like it's never going to end. And one of the challenges in doing callbacks is how do you handle errors? So if we go back over here to the example, you see all that. It calls the function, and it assumes that if there's no error, it's going to give you a list of students in the first one. In the second one, if there's no error, it's just going to give you details about the student. In the third one, if there's no error, it's going to give you a list of all the juniors. Well, what if there was an error in any one of those three functions? And a lot of times when you start writing code, you kind of forget how to handle the error messages that might come up. And it kind of can be difficult to understand because you're looking at things that get nested in, and they can go quite deep when you have a lot of things, especially in a very large application that you might be working with. So the solution to those problems and those challenges that we had with callbacks was that we wanted to end up with promises. Well, prior to ES6, we had a solution to be able to handle promises, and we had to load a library into our code that gave us that functionality of promises. So that added extra code to your code, extra size to it, but you had libraries that were out there that were available. Bluebird and Q are some of the more common ones that people have used to do promises. Now, the good news is in ES6, promises are native into JavaScript. So you don't have to load a third-party library. You don't have that extra size loaded into your application. So now your applications are a little bit smaller. They're based off the Promises A+ standard. So if you Google that, there's a website that tells you about it. And all of the promises that are in ES6 are based off of that. Now, once you have that, hold on. You want to know exactly what is a promise and what is the difference between a promise and a callback. And a promise is just basically says, this will execute eventually when something else happens. Now, that something else may never happen because it might fail, but that's what a promise does. And the advantage of a promise over a callback is that they're composable. And what that means in simple terms is it allows you to take small building blocks of code and compose those together to create something else to get you the final results in your code. So that's one of the advantages that you get with promises. All right. When you start looking at a promise and you start using them, there's basically a life cycle of what it goes through. The first thing you're going to do is you're going to create your promise. Then the code inside the promise runs. And then it's either going to work or it's not going to work. And then whether it worked or it doesn't work, it either it succeeds or it fails. And then regardless of which one it does, it will send out an alert, an immediate alert to let the system know that it's finished. And that's when it comes back into the execution code to handle it. So when you're going through and you're creating a promise, you have to realize that a promise has states. The very first thing in the very first step of the life cycle, when you create the promise, your promise is in a pending state. Then it will either succeed, which becomes fulfilled, or it will become rejected. And once it reaches one of those two states, it becomes settled. Once a promise is settled, it's done. It doesn't come back and re-execute at a later time. It's done once it's reached that settled state. So when you go through and you want to use a promise inside your code, these are the steps that you would go through and do it. A promise is basically, it's an object. And you use it as if you were using it if you're creating a new constructor. So if you've used JavaScript before and you have something that's a constructor, you call it by using the new keyword. So you say new promise, and inside that promise you pass into it what's called, officially according to MDN, is called the executor. And that executor will require two parameters that are passed into it. And normally these two parameters, just for convenience sake, are resolve and reject. And you can call them anything you want, but for simple terms, 6 months down the road, if you're going to come back and look at your code again, or somebody else is going to read your code, it makes a lot more sense if you use resolve and reject. And then when it finishes, it will call the resolve function, and then if not, it calls the reject function. And that's end up how you go through and create a promise. So here's an example of actually creating a promise. So what you have is you have the new keyword, because it's a constructor. You have promise. You have the executor that's in there with your resolve and your reject. And then you basically in here, I'm checking to see if a global variable called name has the value of Jennifer. If it does, then this promise will resolve. It will complete, and it will return success back. If it doesn't have the name Jennifer, then it will reject, and so it will go into the reject handler, and that's what it returns back. And it rejects with the message that says failed. One of the benefits of using promises is that you can chain them. Kind of like what we looked at earlier with callbacks, where you had a callback and then indent and another callback and then another callback and then another callback. They start indenting, and it makes it very hard to read. When you have promises, you can actually end up chaining them because they're an object. So you can end up calling promise after promises. And the code doesn't go into this pyramid indentation. It basically goes in one depth for every single promise that's called. It makes it a lot easier to understand and to read for you to be able to do multiple promises. So what we have is the exact same code that I presented earlier with the callbacks, where everything was indented. Now what you have here is that you have the function called getAllStudents, and then it returns a callback from getStudentDetails, and then you have the .then. The .then is basically when the promise succeeds, and it basically will then go down to the next one. So when you come up and you look at this code, for example, my mother, who's not a coder, she can look at that and she can kind of get a pretty good idea of what's going on with the code. And that's really what you want to accomplish as a developer. You can say that it's going to do all students, and then it's going to do the next function, and then it's going to do the next function. And at the very end, it's going to console log out. So I've got the exact same functionality as I had before, and it makes it a lot easier to read and understand. When it comes to error checking, one of the problems with callbacks was a lot of times programmers didn't do a lot of good error checking on our callbacks. When you have a promise, you can either resolve or reject, and so you can have a .then, which is the success, and you can have a .reject, a .catch, and that happens when the promises gets rejected and goes through. So here is the same thing that we have before, and I've put in error checking in there. So we have all the functions. If any of these promises fail, it's going to drop down into the .catch, and the .catch is going to be past the error, and it's going to handle it. So it's going to be able to account for any error checking that might be going on out there. Now, promise is an object, and it has a prototype on it. The promise object itself has methods and variables available to you to use. And some of the methods that you have available to you on the promise object is a thing called Promise.all. So what I gave before in the previous example, let me go back here, I'm calling multiple functions to execute. You can combine those into a Promise.all. And what Promise.all is expects an array of promises that you're going to pass into it. And what it's going to do is it's going to execute every single one of those promises. And when all of the promises are resolved, then it's going to return to you an array of all the results so that you can see it. So that's the advantage that you can do. It makes things a little bit easier. So for example here, I've got 3 promises that I've just going to call, for lack of originality, Promise 1, Promise 2, and Promise 3. So all 3 of these promises run, they execute. All they do is they sit there and they basically return, text immediately. They don't really do anything fancy whatsoever. So when I call Promise.all, I have my array of promises, so I pass in all of my promises. I have my .then so that when all of them finish, it's going to return an array with all the values that are returned in it. So when I do this console log values at the very bottom, it's going to pass in an array, and it's going to have 3 items in that array, and they're going to be strings, and it's going to be 1 finished, 2 finished, 3 finished. And that's what I'm going to get back from the result of doing Promise.all. So in the previous example, I could have taken all 3 of those functions that I called and put them into Promise.all and used them that way if I wanted to. Another method that's available to you on the promise object is Promise.raise. It's a little bit different from Promise.all. You pass into it an array of promises. And what it will do is it will start executing all the promises that are in that array. And then it will return as soon as 1 either finishes or 1 fails. It doesn't matter which one it is, but it will compare all of them. And it's the fastest one to either finish or fail. That's the results that you're going to get back from Promise.raise. So you have that method also available to you to use.
Why would I care in that scenario? That seems like a very edge case thing. And I would ever have a list of promises.
Yeah, the only one that I've ever seen that I've ever thought was a legitimate way of doing it would be, for example, if you have 2 methods that you go out to, like 2 data centers to get information back from, and whichever one returns the data fastest is the one you want to display. So, yeah, so we kind of use that with our application where we're using AWS and we're in different zones, and so we will call them and then we'll see which one comes back with the data fastest and display it out. But other than that, I'd be at a loss to give you another example besides that one.
Great example.
So.
That would be the only example.
So this gives you an example of promise.raise. You pass it into an array of promises. So our previous example, promise 1, promise 2, and promise 3, instead of immediately resolving with text, then I've done it with all of them with the set timeout. The only difference between them is the amount of time that the set timeout waits. So from promise 1, it's 500 milliseconds, 1,000 milliseconds, and 250 for the third one. So 250, of course, is the smallest one. So when you start looking at this and you call promise.raise with that array of promises, what's actually going to be console logged out on the value is going to be one value in the array, and it's going to be promise 3, because that's the first one to complete. In this case, it completed fine without any problems. But if, for example, if promise 2 failed before promise 3 finished, then you would have gotten promise 2 back as a result. So now,
Can you go back?
I don't have failures in there, so. This gives you an idea of the support of browsers for support for promises. As you'll notice, you normally would say, okay, IE, well, it's, my humor is, were you expecting anything different than this? So, but this is at least gives you an idea if you start to use it. These are the pitfalls that you might have in the support in the browsers. So that covers the first half of my presentation on promises. This last half is I'm going to talk about generators, which is a new feature that's also in ES6. Yes, sir?
Yeah, I have a few questions about the promises. So there was a slide where you showed the catch error. So you have just one catch, so does that catch block catches error for all the promises?
Yes.
So what if I wanted to catch errors for individual promises?
What you would end up doing is you would put the dot catch underneath each one.
Okay.
So each one individually would have their own. So if you wanted to do something particular for each one, then you would do it there. And in my case, just for convenience sake, and also because of the screen size of my example, because I was running out, I'd use one that would handle for all of them.
It stops at the first catch it finds.
Yeah.
And so you can layer them that way. But
Would
with
you
bottom,
chain them?
that's good.
One long chain, like then
Yeah.
catch, then
Yeah.
catch.
Yes.
The other question was so you have the sequential .all verified array of promises will execute them sequentially, and then there was a race which will execute them in parallel, but will finish whenever one of them ends up finishing.
Correct.
So is there something from the async async library that I've used? So they have a function called parallel where you can execute all these promises parallelly, but you would wait for all of them to finish and then
Get the results.
yeah.
Yeah. There isn't anything equivalent because remember the states of a promise. It starts, it's pending, and then it's either going to be fulfilled or it's going to be resolved, and then it's done. It's completed at that point. Once a promise reaches that state, it's done. So there is no thing of let me wait till something else finishes and then mark it done. So you're not going to have that functionality.
But generally, when you get a promise, the thing's already executed, right? The thing's already in process. So by the act of getting parallel, by getting acting promise, you're all really doing some kind of parallel process. That makes sense. For the most part.
I'm not like so if I have 3 promises, they would be executed sequentially.
No, because they're already executed. Imagine like what you're calling to get a promise. That promise is actually calling execution, and it's giving you the delayed result. So what you actually think about what you're getting is not really, you're not triggering the process, you're getting the result once the process is done. The process is already triggered.
Right. So if I have an array of 2 promises, the promise 2 will be promise 1.
It would perform. I can't remember. That's like a really great snippet. There's nothing that they reject at all. They reject.
I mean, I mean, I think one way just to think about it, but one way to think about it is, while there are other paradigms of Promise.all and Promise race and maybe the other things that we can learn, async libraries and kind of do, the real main goal of Promises is to basically have what you would normally have, where you have a function that the result of the function calls the next function, and those chain together to make those one. Yeah, so there's the callback type of thing, but it's really about making asynchronous programming feel synchronous. Right? It's really taking that asynchronous programming and making it feel like this executes, then this line executes, then this line executes. But what's actually happening is it's executing, it's going around everything, and then it's coming back and then executing. So it just makes that feel synchronous because of the nature of the way it's laid out. And the currying and the closure that Promises provide also give you that same flexibility that putting callbacks inside of your functions also have. So you don't lose any of that flexibility.
All right. So to take over from what Joe was saying, talk about code keeps executing and so forth. When you talk about generators, kind of what Joe just said kind of steals my thunder on my slide here. Is, functions basically, it goes line by line and it goes executing everything through. Once the function goes through, it goes until it goes to the end, and then it's done. And that's how you end up with functions. Now, what's new with generators is it looks like a function, but you can actually end up pausing in the middle of the function and then calling it again and picking up to where it was before, and then you can kind of keep looping over in the actual generator. And that's the benefit that it gives you compared to what you never had before in just regular functions. All right, so going through the same process of how do you actually go through and create a generator. It basically is the same thing. You create a function. You create a function, you can give it a name, but you put an asterisk next to the function, and that signals to the code that this is now a generator. And then what they end up doing is that the generator, when it's called, creates what's called an iterable. And an iterable is nothing more than a fancy term to mean something that you're going to loop over. And it will go through and it'll start looping over that until it reaches the done part of the generator. So every time the iterator loops, it's going to return an object, and it's going to have the value that's being returned and the status of done. And done's going to be a Boolean. It's going to be either true or false, meaning, if it's false, then you can keep looping until it gets to the done. When it hits done, it's over, and it's basically finished at that point. So here's an example of how you actually create a generator. So you have your function, you have the asterisk next to it to indicate that it's a generator, and basically it's a very simple function, is that you're going to start with the value of 0, you're in a while loop, and you're going to go in that while loop, and you're going to repeat until the index is, you're going to keep repeating while the index is less than 3. So the first time that you come through this, your index is 0, you're going to hit the while loop while index is less than 3. Yes, 0 is less than 3. So it's going to go inside the while loop, and it's going to hit the yield command. So at that yield command, it's going to yield and return the value of index. So you can see down here in the console log that I'm going to call my iterator and assign it to a variable called gen for generator. And when first time I call it, I get the value, and I have the dot value added on there because the iterator that returns from the generator is an object, and it's going to have done and value. So I'm getting the value on it, and at that point the index is 0. So the next time that I call it in the next console log, where I loop over it to go through it the next time, it's going to go back to where it yielded. It's got the index value is now 1. I'm still in the while loop, so I'm going to now compare index, which is 1, is 1 less than 3. The answer is yes, so it's going to console log it out. Then I'm going to loop over it again. It's going to go back into the while loop, and then it's going to hit, eventually you're going to get to the point where you have 3, and in the while loop it's going to say, is 3 less than 3? That's false. So it's going to drop out of the while loop, and I am now done at that point. So at that point, my value will be undefined, but my done will have a value of true, and I know that my generator has finished executing. So that gives you a simple idea of how to use a generator. And if you want to use generators in your code, like I say, were you expecting something different other than this when it comes to support in browsers? But that gives you an idea of what versions are supported. This gives you my contact information, my email address, so if you're interested, you can contact me and reach me from there.